All right, let's talk about one of the most important and honestly most underrated organs in your entire body. It's this quiet hero working 24/7, managing your body's entire fuel supply. Yep, we're talking about the pancreas.
So let's start with something we can all relate to. Picture this. You eat a donut, or maybe a bagel, a bowl of pasta. Whatever it is, your body suddenly gets hit with this huge rush of sugar. So what happens then? How does your body possibly handle that massive spike and get back to normal? Well, the whole thing is an incredibly delicate balancing act. It's like walking a tightrope. Your body needs just the right amount of sugar, or glucose, in your blood all the time. Too much, and it's toxic. Too little, and your cells are literally starving. And the ringmaster of this whole circus? The pancreas.
So here's our game plan for this explainer. First, we're going to dig into that energy challenge our bodies face every single day. Then, we'll properly meet the pancreas and its star players: insulin, the gatekeeper, and glucagon, the backup fuel. And finally, we'll see what happens when that crucial balance is lost.
You know, every time you eat, your body is faced with this same fundamental problem. As you digest your food, it gets broken down into glucose, and that glucose just floods into your bloodstream. It's a massive influx of fuel, and your body needs a really sophisticated system to use it and store it without getting totally overwhelmed. And this is where the pancreas shines. I mean, sure, it helps with digestion, but its real magic is in these tiny, specialized clusters of cells called the islets of Langerhans. You can think of these islets as the command center for your body's energy, constantly tasting the blood to check sugar levels and sending out hormones to keep everything perfectly in check.
And if you look at what these little command centers are made of, you get a huge clue about what's most important. A whopping 70% of the cells in these islets are B cells, or beta cells. That massive number tells you they have a really critical job. Another 20% are A cells, and the last little bit are D and F cells.
Okay, so each of these cell types has a mission. Those B cells, the ones that make up the vast majority, they pump out insulin, the famous hormone that brings blood sugar down. And the A cells, they release glucagon, which does the exact opposite. It brings blood sugar up. The other guys help out, but for our story, the two main characters, the real superstars, are insulin and glucagon.
So, back to that donut. Your blood sugar starts to climb, and those B cells just spring into action. They release insulin, and insulin acts like a key or maybe a bouncer at a club. Its message to the rest of your body is crystal clear. Hey, we've got a ton of fuel here. Time to open the doors and store it away.
The way it's made is like a tiny, super efficient assembly line inside the cell. First, it's built in a place called the endoplasmic reticulum. Then it gets all packaged up into these neat little bubbles, or granules. Those granules then travel to the edge of the cell and, poof, they're released into the bloodstream to get to work. And get this, it works incredibly fast. The half-life of insulin, once it's in your blood, is only about 5 minutes. That's it. This speed is amazing because it shows just how responsive the system is. It can make these tiny, precise adjustments to your energy levels from 1 minute to the next.
So, what's on insulin's to-do list? Well, its main job is to tell your muscle and fat cells to open up and take in all that glucose from the blood. It also tells your liver and muscles to store that glucose for later, kind of like packing away groceries. It promotes fat storage, helps build protein, and, this is key, it slams the brakes on using fat for energy. Insulin is all about storing, building, and making sure not a single bit of that precious fuel goes to waste.
Okay, but what about the flip side? What happens a few hours later when you haven't eaten in a while and your blood sugar starts to dip a little too low? Well, that's the cue for the A cells. They step up and release insulin's opposite number, glucagon. And its message is the complete reverse. Emergency! We're low on fuel. Release the reserves. And this right here is the heart of the whole system. It's this beautiful push and pull. Insulin sees high blood sugar and says store it, which brings levels down. Glucagon sees low blood sugar and says release it, which brings levels back up. It's this constant, elegant dance between the two that keeps our bodies humming along in perfect balance.
But what happens when this beautiful system breaks down? What if the body just can't make enough insulin? Or what if the cells just stop listening to insulin's signal? Well, that catastrophic failure is the root cause of diabetes. See, when there isn't enough insulin, those gates on the cells basically stay locked shut. So after a meal, the blood gets packed with all this glucose, but it's got nowhere to go. It just builds up and up and up in the bloodstream, reaching these really dangerous levels.
And here's the truly devastating part of the whole thing. While the blood is swimming in sugar, overflowing with fuel, the cells themselves, your muscles, your brain, they're completely starving because they can't get access to any of it.
The source material we're looking at uses this phrase that just hits you right in the gut. It calls diabetes starvation in the midst of plenty. And that just perfectly captures the cruel, twisted irony of the disease. All the energy you could ever need is right there, but the body is completely powerless to use it.
Because the cells are screaming for glucose, the body panics and switches to its emergency backup plan. It starts burning fat for energy at a crazy accelerated rate. But this isn't a good thing. This desperate switch causes a massive spike in things like free fatty acids and triglycerides in the blood, which creates a whole new storm of problems.
And over time, this toxic environment of high blood sugar and haywire fat metabolism just wreaks havoc. It destroys the tiny, delicate blood vessels in the eyes and kidneys. It hardens the big arteries, leading to strokes and heart attacks. And it damages nerves all over the body. The consequences of losing that delicate balance are just severe.
So this all leaves us with a really critical modern-day question. With our current lifestyles and diets, we're putting more strain on this system than ever before. So, understanding this incredible dance between insulin and glucagon isn't just a biology lesson. It's absolutely fundamental if we want to protect our most vital systems for the long haul. Thanks for joining me on this deep dive.